What does it actually take to build a bit of complex interactive UI for a web app? Hi, I'm Mike. I like to make web apps, like this mandala maker. It's a little web app that lets you make colorful patterns in a circular shape, like those coloring books for adults, but digital. Earlier versions of this had a UI on the side that let you type in numbers or drag sliders to change the size, shape, and color of the pattern. I had a lot of fun making the app, and I have a lot of fun making the mandalas with the app, but it's always felt like there was a disconnect between the things I was changing and the picture I was creating. One day I thought, what if I create a widget that gives me direct control over the shapes, similar to what you would see with Figma or some of the whiteboarding apps? In this video, I'll show you all the pieces that go into creating an interactive UI widget with SVG, and some of the problems or issues you might run into along the way. So what's the actual problem that we're solving here? Well, when I select a shape and I change one of these values like scale or radius, there's a direct connection between these values and the change that I see. But how do we do that if we're using a widget where if I click and drag, I want to translate these movements of the mouse into that single value for the rotation or for something like how far it is from the center? The first thing that I need to figure out was pointer position coordinates. I needed an X and Y value that represented where the cursor was relative to the center of the mandala. By the way, this video is going to be code light. I'd rather focus on the concepts, but I will share a link if you want to dive into the code. So there are 4 things that we need to consider when working with interactive UI and SVG. The first and the most common is client X and client Y, which gives you a position relative to the top left-hand corner of the viewport. Second are the bounds of the SVG container, so we know where it is relative to the viewport as well as its overall dimensions in pixels. With those 2 pieces of information, we can calculate where we are from the top left corner of the SVG container. But remember, I care about the center of the container because I'm dealing with a mandala. That's where the third puzzle piece comes in, the SVG property viewbox. It lets us set the dimensions of the container as well as where we want 0 in X and Y to be. You'll need to take this into account when calculating your final pointer position value. And fourth, SVG units are not pixel units. You might have a container which has a width and height of 1,000 units, but if the page element is 500 pixels across, that means you have 2 SVG units for every 1 pixel, and you'll need to take that into consideration when working out your final pointer position value. Now, some of these things might not apply to you, but it's worth running through them first before you spend hours trying to figure out why the shape is moving twice as far as the mouse cursor as you drag it across the screen. Pointer events. I feel like this took me longer than I wanted it to. You see, a lot of the tutorials out there will show you how to click and select a single element. But what happens when you're dealing with multiple overlapping elements that each have their own pointer events? If you're dragging an element and your cursor happens to find itself over another element with its own events, you can run into some issues. In this little demo, I'm clicking on the center shape and then dragging the cursor. But as soon as the cursor hovers over the gray boxes, their hover events fire. The solution to this is the set pointer capture function. By setting this when you first click on an element, you guarantee that only events related to that element are fired. You might also need to look into the CSS properties, touch action, and pointer events set to none to avoid some other unexpected events from firing off. The thing that really unlocked the potential of my interactive widget was finite state machines, and I'll explain why later. But first I need to cover some math. It's not too complicated, and I think these ideas can be applied in a lot of different use cases. So let's talk a little bit about rotation. I've used this one function in everything from video game shaders to complex CGI visual effects. You see, I often need to know the angle between 2 vectors. Or put another way, if I'm looking straight ahead, how do I calculate the angle to an object whose position I know? A102 gives you that. It's pretty straightforward. It takes the y and x coordinates and returns an angle in radians. What makes this function special is that it gives us a value that covers the full 360 degrees of rotation. whereas functions like sine or cos only cover 180 degrees of rotation. Applied to our widget, I can take the coordinates of the cursor from the center of the mandala and convert it into a rotation. Then I can figure out how much I want to rotate my object by taking my current rotation and subtracting it from the rotation when I first click the mouse. The other thing that I find really useful is how to project vectors. When you scale or translate something, you need to know the direction that you're moving in as well as the distance that you've moved. With the mandala, the shapes move outward along a specific locked axis. But what happens when the cursor moves away from that initial direction? And this is where projecting a vector comes in. Let's look at an example. The scale of this box is being driven by how far the cursor is from the center, which is fine when I move the cursor in the expected direction. But as soon as I move away from that initial direction, the box grows bigger because it's based on the distance of the cursor from the center. You can fix this by projecting the new vector onto the original vector. We're asking where would the cursor be if it was still moving along the original direction, and using that distance to calculate the scale. This is a deliberate simplification, but I'm taking the angle between two vectors as the ratio for how long the implied vector should be. It's the function cos. It's basic high school math. For my mandala maker, everything rotates around the center. The shapes move outward from the center, and they scale from the base of their shapes. Why this matters is how I set my transformation order. If I have translate, rotate, and scale as my transformation order, then when I move and rotate an object, the final position is going to be different than if I had rotate, translate, and then scale as my transformation order. It's a relatively simple concept, how these three transformations interact with each other, but getting the order right can make big differences to the final result. Okay, this is the part that gets me the most excited. It's finite state machines, which is super geeky, I know, but it's the fact that I've used them in the past when I made a simple 5-side soccer game, but now I get to use it for interactive UI, and it's amazing how many use cases there are for it. So what exactly is a finite state machine? I think the simplest analogy is think of it like a choose your own adventure book. You read through a page, and at the end, you get to choose which page you want to go to next. And then once you've gone to that page, you're now in a new version of the story. At the most basic level, we have 3 events. We have pointer down, where I click the mouse button down, pointer move, where I'm moving the cursor around the screen, and pointer up, when I release my finger from the mouse button. But even just with those 3 events, there are a lot of different things we could do with our shape. I could move it, or scale it, or rotate it. And that's just keeping things really simple. What if we start adding in other types of events, like middle click or right click, or keyboard modifiers like Alt and Shift if we want different things to happen? You can see how very quickly the matrix of possibilities of these combinations starts getting more complex, and we need a way to manage that. And that's where finite state machines come in. Let me show you. On the right is a visual representation of a state machine. The circles are states, with the red circle being the active state. Think of them like the mode we're in. And while we're in a specific state, we have a set number of possible next states based on an event that happens. Those are the lines between the states. So while I'm in the idle state, the only 2 events that will trigger a transition are pointer down radius or pointer down rotate. Those events are triggered when I click down on one of 2 areas on the widget. So let's click on the rotation handle. Now we're in a new state with new options. I can either release the mouse button, which will fire the pointer up event and take us back to the idle state. Or if I start moving the cursor, we transition to rotating and update the rotation. As soon as I release my mouse button, it fires the pointer up event and we transition back to the idle state. And even though the same event is firing off like pointer move, it only has an effect on the current state if that state has a transition based on that event. This is just a simple example, but hopefully it illustrates the complexity of the situation and how it can help to have a system that manages that complexity. This way, I can define my different states, the events that I want to fire off, and what happens when those events fire off based on the state that I'm in. I wanted to throw this in because I thought it was a nice touch. It's not necessary as such, but I think it's these little details that make an interactive UI feel better. How do we have the cursor icons orient to the widget that we're interacting with? See how the scale icon shows the direction we want to move our cursor in, or the radius handle showing which direction we can move the shape in? If you've done any web development, you probably know that you can assign a cursor icon to an element. You might even know that you can use custom SVG as your cursor icon. But I thought this was a nice touch. You can set the transform property of the SVG so that the cursor aligns with the widget. Isn't that cool? Just be careful if you're using template literals to set the transform property of the SVG, because one wrong quotation mark and the whole thing will fail silently. I wanted to touch briefly on the relationship between UI and UX. I still have a bunch to learn in this area, and there's a reason why people dedicate their careers to these crafts. A lot of what I've shown you in this video was inspired by the whiteboarding app TLDraw. And at first I thought I could just steal or borrow the look and feel of the bounding box widget for the mandala. It's super minimal, but somehow I still knew intuitively where to find the move, rotate, and scale handles. Unfortunately, this didn't work for my mandala widget because I'm not doing common transformations. I only allow scaling from the outside of the shape. The rotation pivots around the center of the mandala, not the shape. And even the movement is fixed along a specific axis, which is in contrast to the freeform positioning that whiteboard apps allow. I had a look around to see how other apps handle this. Excalidraw, for instance, has explicit target zones for each handle that are always visible, making it easy for the user to figure out what they can and can't do. Figma does something similar, but they also have what I'd call special handles that only reveal when you hover over the shape. And then to really make things clear, a tooltip will pop up when you hover over the special handle. You can see how there's a lot of different ways to approach a similar problem and come up with different solutions. This is the beauty of UI and UX design. I settled on something similar to Figma. When you hover over the bounding box of the widget, the target zone appears. To my untrained eye, it feels okay, but it also feels like it could use some more polish. The size and shape of the target zone indicators, the color of the bounding box. These are all little but important elements that go into the design of a well-made interactive widget. So that's it. That's pretty much everything I learned while making this interactive widget, and I hope that some of it might help you if you ever want to do the same thing.